Hello, in this lesson, 3A, we're going to learn how to use lists in Python. Now, a list is similar to an array that you may have used in some other languages. That is, a bunch of values that can all be referred to with a single variable name. However, lists in Python allow you to do a lot of things that arrays in other languages don't let you do. So let's get started.
There are a lot of collection types in Python. The list of this is the one that we're going to spend the most time with, but there's more than one collection type. So let's talk about them. In addition to the primitive data types, Python supports collection types, which contain either 0 or 1 or more elements. One of these is a list. A list is an ordered sequence of elements, each one of which can be any type of Python element. So this is very similar to arrays in other programming languages, but in Python, the elements of a list don't all have to be the same type. Think about it. In Java or C++, if you have an array of integers, you've got every member of the array is an integer. In Python, you can have the first element be an integer, the second one be a string, the third one be a list itself. So here's the syntax for creating them. You use square brackets to create a list. If you do x equals open square bracket, close square bracket, like this, that creates an empty list, a list that has a length of 0. No elements. That's the exact same thing as doing x equals list parenthesis parenthesis. X equals square bracket 1 comma 3 comma 5 comma negative 2 gives me a list that has 4 elements, each one of which is an integer. The next example here gives me a list with 3 elements. First one's an integer, next one's a floating point number, third one's a string. Here, this one gives me a list with 3 strings in it. This one gives me a list with 3 strings in it. It has 3 elements, quote A quote, quote B quote, quote C quote. And here's something that you can only do in Python. X is a list that contains 2 more lists. The first list in X is the list containing 1 and 3. The next list in X is the one that contains the strings apple, banana, and orange. Now you've got to be awfully careful with this much power in Python. You've got to be very careful that you know what's happening with each particular element in your lists. So how do we number elements of a list so that we can refer to them? Well, let's give ourselves a list to play with. Let's say x equals the list made up of elements 5, 7, ABC, and negative 12.5. So you can think of the list as a 5 followed by a 7 followed by an ABC followed by a negative 12.5. We can refer to the elements of a list by using x square bracket and just give it an index number, where Python, like most other programming languages, starts the index at 0. So this is x sub 0, the value 5. X square bracket 1 is the value 7. X square bracket 2 is the value quote ABC quote. X square bracket 3 is the value negative 12.5. You can refer to each element in the list with the index that starts at 0, but Python also lets you use negative numbers for indices, and then it counts off from the right side. X square bracket negative 1 is the same as x square bracket 3. Index negative 1 is always the last element in the list. The second to the last element is element negative 2. The third to the last element negative 3, and so on. Now you're going to need to get used to these. Notice when we're using the non-negative indices, they start at 0 and we go up to but don't include the number of elements in the list. This list has 4 items in it. We can't refer to x sub 4. It doesn't exist. x0 through x3. But when we use the negatives, it goes from negative 1 to negative 4. So a little bit tough to get used to. I suggest, while you're still getting used to using lists, draw out a diagram like this. Start at 0, go forward, start at negative 1, go backwards. You're going to have a few quiz problems this week that are going to ask to see that you know how to refer to various indices in a list. Now, Python also lets you slice a list, meaning find more than one, possibly 0 or 1 or more than one element by giving it a start and a stop and a step, or sometimes also called a stride. So we referred to specific elements like this with just x square bracket 0. When we do x square bracket and we have more than one value separated by colons, the meanings are start is where you want to start, duh. Stop is where you want to finish, except it finishes one before. We'll do examples that help. If I do a start of 0 and a stop of 2, it'll give me elements 0 and 1. And the step says, between the start and the stop, how much are we going to go up each time? Am I going to do every element, or am I going to skip and do every other one, or every third element, or every fourth element? Start is optional. If I leave it out, 0 is assumed. Stop is optional. If I leave it out, the length of the variable is assumed. Step is optional. If I leave it out, a 1 is used. So you can see when we referred to just x square bracket 0, that was a slice where I left out the stop and the step. Here's some examples. Let's let x be this list that contains an integer, a string, a floating point, a boolean, another integer, and a list. So it's got 1, 2, 3, 4, 5, 6 elements in it. If I do length of x, I get a 6. If I do x 2 colon, it says start at position 2. Here's position 0, position 1, position 2, and go up to the end. So I get 7.21, false, negative 3, and the list 0, 0. If I do x minus 2, it's going to start at negative 2 and go to the end. Well, where's the negative 2 position? Here's negative 1, here's negative 2. So it starts at a value of negative 3 and keeps going. If I do x from 3 to 5, it goes, well, here's 0, 1, 2, 3. It's going to start with false. Here's 4. Here's 5. It's going to stop right before it gets to 5. So this says start at element 3, go up to but not including element 5. So I get the list that has these two elements. If I do x, no start, no stop, but a step value of 2, that means start at the beginning, go to the end, but only do every second value. So I get 5, 7.21, negative 3. And if I do x colon colon negative 1, it says use a negative value for the step. So I'm going to go backwards. I get the last element first, then the second to the last element second, then the third to the last element third, fourth to the last element fourth, and so on. So take a look at these examples. In fact, I would encourage you to open up idle and in the Python shell create a list and play around with some slices until you're very confident of what they do. Now, in addition to slicing lists, there are a number of methods that are built into the list class. So let's suppose L is the name of a list variable I've created. Here's some methods you can use. Probably the most common is L.append and then give it something in parentheses. It adds one element to the end of the list. If the list had 7 items in it, now it has 8. If it had 0 elements in it, now it has 1. Whatever you give it gets added to the end of the list. Or I can do L.extend. Now for that, what I pass in parentheses has to be something that itself is a collection. So maybe M is another list. Maybe L had 3 elements in it, M had 2 elements in it. When I do L dot extend M, I'll get the 3 elements from L plus the 2 more elements from M. By the way, if I go L plus equals M, that means exactly the same thing as extending. L dot count. Count how many times the value X shows up in L. L dot index. Tell me the first place that X shows up in L. Oh, and you can give it a start and an end if you want. Otherwise, it assumes you want to go through from the very beginning to the very end of the list. So it'll say, yep, I found X, and it was in position 4, or position 0, or position 7. If I do L dot insert IX, it says put value X into the list L right before position I. If I do L dot pop, that removes and returns the last element of L. It gets rid of one element of L. L is now a list that's one shorter than it used to be. And it returns it, so I could assign it. Or I could pop a specific value. Yeah, I know, this is an awful lot of things. We're going to go into idle and play around with some of these in just a minute, so bear with me. L dot remove X removes the first element of L that happens to equal X. Reverse switches the order of everything in L. We already saw how to do that with a slice. And L dot sort will put all the elements of L into ascending order, but only if it can compare them. If they're all numbers, it can work. If they're all strings, it can work. If you've got some numbers and some strings, yeah, it won't work, because it can't compare the strings to the numbers to see which is bigger and which is smaller.